Okay. Hello, everybody. It is, I don't know, what is it? Today's June 4th, I guess. But it is time for another
I
development
hope so.
workshop. Yeah, I'm Emily. I'm your host today. I do DevRel at Linea, but I'm not important. The most important person is our guest here, Ariel. So, Ariel, will you please introduce yourself?
Yeah, sure. So my name is Ariel. I'm the CPO at SphereX. We're a blockchain security company based in Tel Aviv. What we do is we provide on-chain decentralized exploit prevention solution for smart contracts, which I will explain in more detail in a few moments.
Okay, awesome. So I understand you have slides, right? So I feel like we could probably just jump into it because my next question is like, what is SphereX? Can you explain more about it? Um,
Sure.
yeah.
Let me just share my screen. Okay. Can you see my screen?
Yes. Cool.
Perfect. Um, so, what we do at SphereX and why we're different from other types of blockchain security. So, SphereX is the first on-chain decentralized exploit prevention solution for smart contracts. We all come from security background and also blockchain background. And we came to this world and thought, okay, what can we provide smart contracts with to prevent the most harsh security breaches that we've seen in the past few years. So what we came up with, we have an on-chain integrated security modules that smart contracts owners can add seamlessly to their contracts that will provide them another cover against exploit transactions. I forgot to mention, feel free to stop me at any point and ask any questions. We also have the comments that you can send over, and I'll make my best to answer. So the SphereX SphereX solution, SphereX Protect is comprised of the on-chain part and the off-chain module. The on-chain part is a set of smart contracts that integrated into the protocol smart contracts. So we have the SphereX protected smart contracts, which is an abstract smart contract that your contracts inherit from. And we have the engine. So imagine your protocol is comprised of several different smart contracts that communicate with each other, right? So every smart contract there will integrate with SphereX protected, will inherit from this contract, and will communicate with a single SphereX engine that is a dedicated one for your protocol, but all your ecosystem contracts communicate with this engine. I'll explain in a minute what the engine does. Does this make sense so far? I hope this abstraction works. Okay, so once everything is integrated, what happens is a transaction is being sent to one of your contracts. Your contracts communicate through the protected contracts, communicates with the engine. The engine gathers data points while the transaction is being executed. Those data points, from these data points, that could be message data, it could be the current function being executed, it could be any state changes in your contracts. Those data points are being transferred in a read-only manner to the engine. The engine gathers these data points, and at a certain point, the engine can decide whether, from these data points, whether this transaction is something that is anticipated or a unique one or might be a malicious one. So essentially, a protocol is a state machine, and every transaction changes the state of it. But the transactions for most protocols share the same fingerprints of how the state changes. An exploit or a vulnerability is essentially an unanticipated way to change the state of the protocol. And this is exactly what the engine and the SphereX protection tries to prevent, and malicious state changes in your protocol. Now, because this solution is on-chain and part of your protocol, this solution is decentralized. it is hermetic in such a way that it cannot be bypassed, like solutions like monitoring on front running. An incentivized hacker can just pay more gas to bypass or combine the whole exploit in one transaction, that or send it through a private mempool and bypass any security countermeasures out there. But because this security countermeasure is part of your contract, part of the transaction execution, it cannot be bypassed. This is an important part of SphereX solution. Hope this makes sense.
Cool. Yeah, I have a question, I guess, just to
Sure.
interrupt here. So, does including SphereX like incur an extra gas cost then?
Yeah. Okay.
Okay.
So you're right, because we're part of the transaction execution. It does add a bit more gas to the transaction execution, but we've made tremendous efforts in reducing these gas costs. From our backtesting on numerous of protocols, the extra gas is between 10 to 20% of overhead. Of course, in L2s like Linea, which has promised a very low gas fees, that doesn't really. We have customers on Linea that doesn't really feel this extra gas cost.
Okay. Cool. Yeah, makes sense. I guess to that point, maybe I'll ask this question later. Maybe it makes sense later. So
Sure.
I'll let you continue and then find a
Okay,
better place to
sure.
ask it. Yeah.
Okay. So how does the Sphere extension detects those malicious transactions? So what we do is we add to the Sphere extension a set of rules of how your specific protocol operates and how those states are being changed. So once those rules are uploaded to the engine, the protection is being applied and malicious transactions would be reverted. And it's important to say that all the SphereX engine could do is either let the transaction go through or revert the transaction. We don't have any access to any other resources your protocol has. No funds are being transferred, no execution is being added to no state changes are being transferred from the engine to your contract. So that is an important aspect of how we design the solution. Now, those rules are not an arbitrary black box rules. What we do is we backtest your protocol and we run it through a simulation. And we take every transaction that has ever been sent to your protocol and we analyze it off and we extract those behavioral fingerprints of how those transactions affected your protocol. Then we compile those transactions to a set of rules that are then uploaded on chain. So everything is predictable, everything can be checked on chain, and those rules are dedicated set of rules to a protocol based on your history. So what we do essentially is harden your protocol to be anticipated in terms of how it previously operated. Okay.
Cool.
Any questions so far? Maybe from
Mm,
the audience. I guess not.
probably not. Yeah.
Okay. So this is the basic design. Let's see, first of all, how one can integrate SphereX into the protocol, and then we'll see how the protocol is being seen from the SphereX dashboard. Okay. Okay. Can everyone see my screen?
Yep.
Great. So I was told this is a developer workshop, so there is a bit of code here. We've backtested the solution on numerous protocols. Most of them have been hacked in the past. One of them is the notorious Poly hack. What happened in Poly? This is one of the biggest hacks in blockchain history. I think hundreds of millions of dollars were stolen from the Poly breach. And with what we did, as we do with other hack protocols, is we integrated into this protocol and we simulated all the protocol transactions to see whether we were able to detect the malicious transactions and prevent the hack from happening. So first of all, we need to integrate SphereX into the protocol. What you can see here is the protocol code, okay, of the Poly bridge, the Ethereum side of the Poly bridge. And it's important to know that we have two types of integration. The first one would be for immutable protocols, that would be to add modifiers to some of the functions. Okay, because immutable protocols has only the implementation that is being deployed on chain, we need to be part of the implementation. So this is the original code of the original Poly code. We've um, we've created a small CLI utility that can just run the integration, and we'll see it's going to take a few seconds. Great. So what can we see here that happened running the integration? You can see that there's another import to the contracts, okay? And we can also see that for some of the functions, modifiers were added. Those modifiers will in turn be calling the engine while the transaction is being executed. So we pass a few data points to the engine, like the number of the function, the selector of the function, and other types of on-chain data that is being passed to the engine. We can see here the contracts that were patched, that the modifiers were added to, and the inheritance tree of the Poly contracts. And in blue, you can see all the contracts that modifiers has been added to. Okay, so this is all the integration that needs to be done. Okay, nothing fancy, just adding modifiers to the code. This is for immutable contracts. For upgradable contracts, which use proxies, we have an even better solution for the integration. Just a sec. Okay, so for upgradable contracts, instead of modifying your implementation, we can actually add the integration to the proxies. So instead of calling the proxy, calling the implementation, then the implementation calling the SphereX engine, the proxies can call the engine before it calls and after it calls the implementation. So we've created and modified the protected versions of the OpenZeppelin contracts, of the OpenZeppelin proxies, sorry, that you can just deploy instead of the original OpenZeppelin proxies. So no implementation changes needed to be done. Just deploy those protected versions of the proxies. Okay, so this is basically all the changes that needed to be done, either using a simple CLI tool that adds modifiers or deploying protected versions of the proxies. Okay. Now you're ready to be deployed in a protected fashion.
Okay. Very cool. Oh, that's very simple.
It is.
Yeah,
Yep.
yeah. I guess like, are there cases where it's like you should, how do I describe this? Like using SphereX, like what is like a place where you should be using SphereX versus like maybe it's not as important. I don't know how to word this, but like how do I say? Okay, maybe we'll just start with like optimal use cases for SphereX. Like if you're building XYZ dApp, this is when you should be considering it.
Okay.
Alternatively, is the answer every single dApp you build, no matter what, you should be using.
Now, half a year ago, I would answer this question as if you have if you have modified versions of protocols or you write your own protocol, you should be deployed with SphereX. If you use generic contracts like OpenZeppelin or Third Web, and that's it, then you might not need this extra layer of protection. And then came the Third Web hack, which showed that even in the most generic smart contracts, there could be vulnerabilities involved. So vulnerabilities, as I previously mentioned, are unforeseen cases. And I mean, we're all human beings. We all make mistakes, and you need to be, but you do need to put every available kind of manager out there in order to protect a huge amount of funds, and this is what we're talking about essentially. So I would say every smart contract out there that has a lot to lose, but even before it has a lot to lose, because you need to think about it from day one, you need to have SphereX integrated.
Cool. Is there like a place where, so I guess we have a lot of users in the chat today. So users who want to use dApps protected by SphereX, like how do we know?
Okay,
Um, yeah.
that's a great question. So SphereX adds a few functions, a few management functions to the ABI of the contracts. So you can just go to either scan or linear scan or any other type of scan and see the ABI of the protocol you want to communicate with, and see whether it has SphereX engine address configured and other types of SphereX functions inside the ABI. We will also be providing a dashboard showing all the contracts and protocols that are currently protected by SphereX.
Okay, cool. So I guess right now the process is if you're exploring something, um, you're gonna have to do it manually. Go to
No,
like linear scan, and then later on we can
we will provide
anticipate
it.
explore. Okay, okay. Do we
Yeah,
have a date? When is the dashboard? No secret.
we should have one. It would probably be in a month or two. Yeah,
Okay.
that's down the roadmap.
Yeah.
Um, Yeah, I mean, we have customers already deployed with us on Linea, also on Mainnet. We have customers that are already protected on BSC. And I forgot to mention that we support every EVM chain out there because our solution is in the EVM code.
Mm,
It just can be replicated to any EVM based L2s or L1s out there.
yeah, yeah. So I guess SphereX probably makes the most sense for like DeFi protocols. I'm curious amongst like the use cases in Web3. Like are you like even like a simple NFT contract, is that something that SphereX would be part of the process for? I'm actually not familiar with the third web hack, so that would
Okay.
actually be some good context to have.
Sure. So what happened in the third web hack is, I mean, it wasn't a hack; it was a vulnerability that was found and fixed by third web team, but it was a bug in combining two Open Zeppelin contracts. There was the multi-call contract which is very common among DeFi protocols, and combining it with meta transaction contracts. So combining both of them together, one was able to send transactions as if it was from the owner of the protocol in some cases. So what we were able to show is that if you would have deployed a protected version of the third web contracts, you were actually protected against this kind of vulnerability. And without knowing the details about the vulnerability, we were able to show we have a protected version of this kind of vulnerabilities, which was amazing uh, to not knowing the details of the vulnerability, but able to prevent it.
Yeah. Oh, that's really cool. Wow. I've never heard of a solution like SphereX before, to be honest. I think not that I'm asking. I don't know, is there anything else out there that's similar to you guys, or you're one of a kind?
Yeah, not that we're familiar with.
Mhm.
We do see a shift of traditional um, security, blockchain security companies that try to provide similar context, maybe. But
Mhm.
yeah, I would say we're one of the kind.
Yeah, yeah. It's really
Yeah.
interesting. I'm glad that we had this call because I had just recently been hearing some buzz about you. Someone was like, "Oh yeah, have anyone heard of SphereX? Like this
Wow,
is really cool." And I was like, "Oh wait, actually, I'm
that's
talking to
nice.
Ariel on Tuesday." So yeah, it is a really interesting solution. I would have never thought of it, but I guess if I had, I would also be doing a different job. That's always my
Yeah.
thing. I was like, "Oh, if I had an idea." Um, but yes, I do want to make sure that people have like links to everything. Like if you could send me the website or like the Twitter, how to get in touch. I'm assuming all of this code is in your documentation, right? If
In our
people wanted to
documentation,
actually
on our
follow.
website, in our GitHub organization. You can see everything. Everything is every deployment we do is verified. We were audited by Open Zeppelin, so yeah, everything is just out there. Yeah,
Okay.
I do want to also mention how the protocol looks like once it is being protected by SphereX. If that's okay with you.
Yeah, of course.
Okay, so let me share my screen. So we stopped at the stage where Poly has a protected vision now. Um, just a sec. Yeah. Now we can actually look at the protocol from SphereX perspective, right? So what you can see here is the dashboard. And for every transaction that involves one of Poly's contracts, we get notified and adding it to the dashboard. So you can see here the addresses that are protected by SphereX now. You can see the amount of transactions that were analyzed by the SphereX engine on chain, and you can see the number of fingerprints or rules that were produced by the system. So you can see that this protocol is pretty much anticipated because out of the hundred of thousands, thousand transactions that passed through the protocol, they all share 24 fingerprints, right? So SphereX was able to cluster the behaviors of the transaction, compile it to a set of 24 rules, and then pretty much the protocol is anticipated and can be protected in the future. So you can see the amount of transaction that the protocol received. You can see the amount of false positives that the protocol, the false positive rate that the protocol endured. So you can see that out of the 125,000 transactions, only zero point zero 0.02 transactions got reverted. Okay, so the false positive rate of SphereX is pretty low. Almost all the protocols that we've analyzed were below 0.1% of false positive. You can see over time the new rules that are being added. And it's not enough to say, okay, we saw a new transaction, we validate. We need to actually explain what caused the engine to revert the transaction. So we can actually dive into every transaction and see what happened there. So let's dive into one of the transactions. Here we can see an unanticipated call flow in which ETH Cross Chain Manager called execute cross transaction, which then called put cur epoch on pub key byte. Yeah, a long function. So this is a new type of call flow that this is the first time that the protocol has ever received, has ever transitioned in this manner, its state. You can see that in previous transactions, there was all these functions involved, but none of them had execute cross-chain transaction called this function. This is the reason why the engine decided to revert this transaction. Okay? And this is essentially the poly hack, in which a hacker was able to change the owner private keys and then in a later transaction drain the poly pools, draining it from hundreds of dollars that were inside.
Yeah.
So again, without knowing the details of the vulnerability that has been included in the poly code, we were able to prevent those malicious state transitions. This is how we stop hacks from happening. This is how we stop exploiting vulnerabilities. Okay. So yeah, if Poly was protected by SphereX, it wouldn't have suffered this type of exploit.
Yeah. So this is the view from the developer side, right? Yeah.
Yeah,
Okay.
exactly.
Cool.
Yeah.
Yeah.
So this is essentially what SphereX does. Again, we've backtested the solution on numerous previous hacks, and we were able to prevent more than 90% of the analyzed hacks. And we're eager to be included in more protocols.
Yeah. Wow, that's wild. I guess, yeah. When did you guys come about? I feel like, how long have you guys been around for?
Yeah, so we started on July 2022.
Oh, okay. So very recent. Yeah.
Yeah, but yeah, bring impact to this world, and we feel blessed that we have these capabilities and help protocols prevent attacks from happening, and helping protocols be deployed in a more protected fashion and get more of the community trust that is
Hmm.
mostly needed because security has been a pain point in the past few years in terms of DeFi protocols. And
Yeah.
that's essentially what we'd like to achieve: more trust, more customers, more community driven back to the DeFi world.
Yeah, absolutely. So, sorry, what is the SphereX website actually? I can't find it from like a
Sure.
simple.
So the address is spherix.xyz.
Okay. Cool.
Okay, you have there all the resources, our audits, our docs, our technical light paper. You can go ahead and look at everything there. You can go over to GitHub and see the code for yourself and analyze the code if you like. And feel free to contact us and ask anything. We'll be more than happy to help.
Yeah. Yeah, this is super cool. Um, I don't know, did you have anything else you wanted to talk about? Um,
Sure. So apart from providing exploit prevention, we do also provide, because our solution is modular and you can plug in every module that you like to be called in a safe manner, in a read-only manner, without affecting your implementation. So we do provide also integration into compliance modules and regulations and rate limiting, which we don't use in the exploit prevention, but those are also the services that we provide to those that integrate with SphereX if these kinds of services are needed.
hmm. Okay. Cool. Is there anything else? I don't want to like if we're wrapping up at the 30-minute mark, we can wrap up at the 30-minute mark. But I just want
No,
to.
sure. I mean, I, I would like to answer any questions out there, but I don't know. Let's see in the chat, maybe. A lot mention frogs chain. Yeah, nice.
Yeah, there's a really big frog community that has been doing a lot of partnerships with various protocols across Linea. Um, yeah, dev tooling side, not so much. Though we do have, I guess, like an online hackathon going on this month, where the Frog NFT project is actually, I think they're handing out $2,000 for any projects that integrate the Frog
Wow.
NFT. I think they did
Nice.
this in April and someone made a little game. So yeah, I guess if anyone's building something with frogs for May, or so sorry, it's June. For June, you can also integrate SphereX. You'll get bonus points first off.
Yeah. If any frogs out there would like to integrate the SphereX, just ping
Yeah.
us. Yeah, we'll be more than happy to help.
No, yeah,
We love
protect my
frogs.
frogs, protect the pond.
Yeah, exactly.
Uh,
Yeah. Um, yeah, again, if anyone out there would like to test the SphereX integration, we'll be more than happy to help. Just ping us using Telegram or on our website. We'll be more than happy to provide you and help you with the integration and show you a demo of how your protocol would look like integrated with SphereX. Again, we'll be more than happy to help.
yeah. Awesome. This is super cool. I'm excited to tell all my friends about it. So,
Great.
yeah,
Yeah.
awesome. I guess it doesn't seem like we have any questions today. So I'll count down for 10 in case there's video lag, which there usually is. Um, and if
Okay.
not, then we'll wrap up. I mean, all the information is online. Um, and yeah, feel free to get in touch with Ariel or the SphereX team. We can always direct you in the correct direction. So yeah, uh,
Great.
starting from 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay.